Okay, so today we're going to look at what's called the ambiguous case with the sine rule. So it's just a couple more steps added onto the sine rule that we need to be mindful of when we're doing the law of sines. So the name, by the way, the name, the ambiguous case, is not important. That's just what it's called in mathematics. Okay, so remember back to the unit circle and the fact that if we're finding sine of an angle, we've got CAST, right? And if we get sine of an angle as a positive value, like positive 1/2, we know alpha hopefully is going to be 30 degrees. And we know that that's going to exist in quadrant 1, but also in quadrant 2, right? Because sine is positive both in quadrant 1 and quadrant 2. So therefore, the solutions to that are 30 degrees for theta, and in quadrant 2, theta is 150 degrees, right? We can do 180 minus the alpha, and we get theta in quadrant 2. So sine, the big idea here is that sine is positive both in quadrants 1 and 2. Okay, so when we're doing the sine rule, we just have to be conscious of that, and knowing that the angles of a triangle add up to 180 degrees. What that means is that when we're doing the sine rule and we're finding an angle, it's possible that the angle could actually be in quadrant 2, or in other words, an obtuse angle. So we're going to look at that. So the setup is totally the same. So, and by the way, the only time this happens is with sine rule. With cosine rule, cosine is positive in quadrants 1 and 4, and in quadrant 4, that's an angle between 270 degrees and 360 degrees, right? And there's no way we can have that kind of angle in our triangle, nor can we have a negative angle, like negative 30 degrees is in quadrant 4, but that doesn't make sense in a triangle. We need to have our angles to be positive, and we need them to all add up to 180 degrees. So with cosine rule, we don't even have to worry about it. With sine rule, the only time that we have to worry about it is when we're finding an angle. And that's because we could have an acute angle, or we could have an obtuse angle, an angle in quadrant 2. Okay, so setup is the same. We're going to have sine of the angle C, that's what we're trying to find, over 12 is equal to sine of, oops, I could have used these ones. That's more fun. So sine of C over 12 is equal to sine of 28 over 8. Okay, and then we're going to rearrange the equation by cross multiplying. We'll get the variable alone eventually. So we'll have 8 sine of C is equal to 12 sine of 28. When we cross multiply, we'll divide both sides by 8. And then we'll take, so we've got sine of C equals 12 sine of 28 over 8. And then to move sine to the other side, we'll do sine inverse of that fraction. And that'll give us C alone. Okay, so in our calculator, we would then do that, right? So first of all, make sure that you're in degrees. And then we'll do sine inverse of brackets. There we go. 12 times the sine of 28, and this will be divided by 8. Okay, and we've got about 44.8 degrees. So really what we've calculated there is alpha. So for sure this is a solution to our triangle. So for sure one of our solutions can be 44.8 degrees. It is possible that there is another solution. Okay, so if you think about it in terms of solving a trigonometric equation, sine is positive, right? So, or sorry, sine of c is positive. This is a positive value. So we're looking at our solution being possible in quadrant 1. So alpha is 44.8 degrees, and theta for sure happens to be 44.8 degrees. But we also need to check, is this one another possible solution? Okay. So in other words, is 180 minus 44.8 degrees a possible solution? Okay, so is it possible that that angle could be 135.2 degrees? Okay, so to check that, yeah, so we've got 44.8. We're going to use that kind of as our alpha. We subtracted it from 180 and we got 135.2 degrees. So we need to check then to see if this obtuse angle is even possible. So just so you can visualize this, we've got, right, so for sure we've got 44.8. By the way, this triangle is not drawn to scale, just so you're aware. So for sure, this triangle, where we've got a side length 8, we've got a side length 12, we've got an angle of 28 degrees here, and we know for sure one of our solutions is going to be 44.8 degrees. So for sure, this is one solution. Okay, and that's the acute solution of angle C. The acute solution is always going to be a possibility, or it's always going to be a solution. Okay, the other option is to swing this side length 8, to swing it over here, and that's going to create another triangle where we've got an obtuse angle here. Okay, and that obtuse angle happens to be 135.2 degrees. And look, we've still got a side length 8, we've got a side length 12, we've got an acute angle of 28 degrees. So we need to check, is this even a possible solution? And the way that we do that is we just make sure that these two angles, the 135.2 and 28 degrees, do not add up to more than 180 degrees, because then it won't create a triangle. So we just have to check is there still room for another angle here, you know? So if we do plus 28 degrees, so remember 28 was our original angle that was given to us. So that's 163.2 degrees, which is less than 180. Therefore, it's possible that, yes, this is another solution. So we actually have two solutions here. We have the acute solution, which was this green triangle. So this is one solution. And then another solution is that angle C can be 135.2 degrees. And the way that we know that's a solution is because this is less than 163.2 degrees when we add up the angles of this triangle. So that means it's still possible that this angle, angle A, can exist. And we actually know if we calculate that, we can do 180 minus this. And we know it's going to be 16.8 degrees. Okay, so it leaves room for that angle. And we don't have to find that angle as part of our solution anyhow. But just so you're aware. Okay, so our two solutions are 44.8 degrees. So C, angle C is equal to 44.8 degrees, and it's equal to 135.2 degrees. Okay. Okay, so more examples like that with less explanation, and hopefully we can just go through the steps. So here we're going to set up the sine rule. So sine of A over 12.6 is going to equal sine of 65 over 15.1. Okay, we're going to cross multiply, so we've got 15.1 times sine of A is equal to 12.6 sine of 65. We're going to divide both sides by 15.1, so we'll get sine of A equals and then we'll take the sine inverse of both sides. So A is equal to the sine inverse of that fraction. Okay, so we'll do sine inverse of 12.6 times sine of 65, oops, divided by 15.1. Okay, so that gives us 49.1 degrees. So for sure, this is one solution to our triangle here for angle A. So this, for sure, angle A has to equal 49.1 degrees. Okay, we also want to check, is it possible that we could have an obtuse angle for angle A? So right now we found for sure one of our solutions is 49.1. We want to check, is it possible that another one could be this obtuse angle that actually lies in quadrant 2? So we're going to do 180 degrees minus 49.1, which you can think of as our alpha. So 180 minus 49.1 is 130.9. Okay, so we need to check that this is a possible solution. So if we have angle A is equal to 130.9, and then we add that to angle B, so this angle here, 65 degrees, is that going to be too much? Is that going to be more than 180? So 130.9 plus 65 and yeah, that's 195 degrees, which is more than 180 degrees. So this is not a possible solution because it gives us a triangle that adds up to more than 180 degrees. So the only solution is 49.1 degrees. Okay. Okay, second example here, we've got sine of B over 38.4 equals sine of 43 over 27.6. So if we cross multiply, and actually if we just leave sine of B by itself, we'll have 38.4 times sine of 43 over 27.6, and then we can take the sine inverse of both sides. So that gives us B is equal to the sine inverse of this. So sine inverse of 38.4 times the sine of 43 and divided by 27.6. And that gives us 71.6 degrees. So B for sure is equal to 71.6 degrees. So that's for sure one of our solutions. Okay, so then we have to check, is there a possible second solution? Is it possible that B could be an obtuse angle? So we've got 71.6 for sure is one of our solutions. We need to check, could we have 180 minus 71.6 as our solution? Which is 108.4. Okay, so our original triangle, we have to figure out, okay, if we add 108.4 plus 43 degrees, is it going to be less than 180? Is it possible that that could be a solution? We use 43 degrees because that's this other angle that we know for sure is part of the triangle. And we can see that that's not going to be more than 180 degrees, but just to be sure, we've got 151.4. Okay, so that's less than 180 degrees, which means 108.4 is another possible solution. So what we got here, when we did 180 minus our alpha, that's another possible solution. So one solution is 71.6 degrees. The other solution is 108.4 degrees. Okay. Okay, how many more examples do we have? That's okay, last example. So we've got a triangle with sides lengths 10 and 11 centimeters. And an area of 50 centimeters squared. And we want to show that the included angle may have two possible sizes. Okay, so remember area of a triangle, or you don't actually have to remember this, but because I'll give you the formula on the test, but area of a triangle is equal to 1/2 AB times the sine of C. So let's call this C, let's call this A and B. Okay, so 50 is going to be equal to 1/2 times 10 times 11 times the sine of angle C. Okay, we're gonna, okay, this is 50, yeah. So if we divide by 5, we've got 10 equals 11 sine of C, and 10 over 11 is equal to the sine of C. Okay, and then we'll do sine inverse of 10 over 11. Okay, and that's 65.4 degrees. Okay, so that's one solution. And even though we're not doing law of sines or sine rule right now, the fact that we took the inverse of a sine function means that we always have to check that there aren't two solutions to this triangle. So we've just found alpha, which is 65.4 degrees. We know that sine is also positive in quadrant 2, so we need to check if that's a possible solution. And actually, in the question, it says show that the included angle may have two possible sizes. So we know that, yeah, we're going to expect that there's two solutions here. So one of them happens to be 65.4 degrees. The other is going to be 180 minus 65.4 degrees. Okay, so that's 114.6 degrees. Okay, so we've got 114.6. We want to make sure that if we add it to the existing, all right, we don't have any existing angles, so that's perfect. So already this angle is not more than 180 degrees, so we know that that it's also another possible solution to our triangle, because we don't have any values for these missing angles. So as long as this is not more than 180 degrees, then we know that it's going to be one of our solutions as well. So when you're doing law of sines and when you're finding the missing angle when given the area of a triangle, you should always check for two solutions. Okay, so that's it. Thanks a lot.